Hi, my name is Matevz. I'm a software engineer at the Oasis Protocol Foundation. And today I'm going to talk about the hot topics we're currently tackling at the Oasis. Before we start, I just wanted to ask you, how many of you program in Solidity? Yeah, heads up. Okay, cool. And what about in Rust? A single one. Okay, not bad. 2, yes. Okay, awesome. Let's talk about confidential blockchain and why are we doing blockchain from the first place. So it's a distributed network of nodes, right? There is no centralized authority, no censorship, which is great. Computation is very robust. It's completely redundant. So is the storage. Every node stores everything and knows about everything that's going on chain. But there are also some caveats, right? Because it's a complete redundancy. The storage and the computation is really expensive overall. We have a blockchain which consists of blocks, right? So despite having an instant finality, for example, at Oasis network, you still have to wait for a block time in the worst case. So this is 6 seconds in our case. So expected time is what, about 3 seconds, which may be too much for some applications. And finally, at least in Ethereum, a world state trie is completely public, it's transparent to everyone, transactions are public. So at Oasis, this was years ago, we developed a confidential EVM compatible blockchain. We call it Oasis Sapphire. So what do you get? You get an encrypted contract state. This means that everyone will be able to access any contract, but it will not be able to see what's inside the contract state. Then you have transactions. All transactions can be end-to-end encrypted. So the whole ledger of transactions will contain, well, it will contain normal transactions. Everyone will see those transactions, but the content, the call data of those transactions will be encrypted. You will still see the from, the to address, the gas information, but not the call data itself. We are EVM compatible, so even though this sounds awesome to have an encrypted contract state, we are still try to be EVM compatible, apart from that ETH get storage at calls, for example, that gives you the contract storage state, which cannot work in our chain, of course. How do we do it? Well, we run the complete Sapphire EVM inside the trusted execution environment, Intel SGX to be more precise. So this is how we preserve the privacy. So every node operator who wants to be a compute node needs to have SGX support, and he has no idea what exactly is going on inside the trusted enclave. Right, so on the client side, if you want to have encrypted transactions, you need to use our wrapper for either TypeScript, Go, or Python. And then all the queries and transactions will be end-to-end encrypted. So on top of that, we also extended the functionality of Solidity. We offer sapphire.sol library, and you can do some really exciting stuff with it. You can have a random number generator, which runs completely on-chain. And then since you have random numbers, you can also derive new key pairs. And once you have key pairs, you can sign messages, you can encrypt, decrypt everything on-chain, which is really, really cool. And for those of you who maybe are familiar with the sign-in with Ethereum, SIWI, so this is a mechanism developed a year ago, basically for users who have a MetaMask wallet and they want to use some Web 2 applications, and without having email address and so on, they can just log in with their Ethereum wallet. Well, now we support SIWI parser on-chain, so you can now have a complete Web 3 application running completely on-chain. Even the message, the SIWI login message, can be parsed on-chain. For cross-chain communication, we have OPAL. It's an abbreviation for Oasis privacy layer. So if you have an app running on some other chain and you want to have some portion of that app running on the confidential chain for managing confidential data or some logins, keys, whatever, then OPAL uses Seller bridge under the hood. So we prepared some basic building blocks for that. And now to illustrate this, so basically you import our Sapphire sol library. To generate a random number, simply call sapphire.randomBytes, and this will give you, in this case, 32 random bytes. And then if you want to return a favorite number of your user, or if you won a lottery, for example, or if he got a swag or not, you just do the modulo operation and extract the number. Or if you want to generate a key pair, you call the generate signing key pair function, providing the seed. We also support the SecBit56 as well as the ED25519 encryption scheme. Then you can encrypt and decrypt on-chain. These are all precompiled, so they're very cheap. Then you can sign a message and verify if the signature is correct. And there's also one cool thing you can do with it. You can also generate an Ethereum transaction on-chain and sign it on-chain. And then you can sign it with some account which is funded. So basically, you get the gasless transactions for your users very, very easy. So those of you who follow the account abstraction debates in the Ethereum world, well, this thing is much easier. It's a straightforward implementation of the simple, signing the transaction, and it already works like today in production. And finally, I mentioned Siwi before, so this is the nice pop-up MetaMask shows you if you want to log into some app. And how we do it? Well, you store the domain where your dApp lives inside the smart contract, and basically the user then calls the login function of our contract. Our parser checks whether the login credentials match the signature of the message, and then it obtains the bearer token, and with that bearer token, he can then proceed doing some confidential queries to your smart contract. And this in this code here, this auth message sender helper will extract the proper message sender from the bearer token the user is providing each time he tries to communicate with the smart contract. Okay, but this is all blockchain, this is all on-chain, and this is so 2023. This is what we did in the past. Sapphire is now, I think, 2 years old. It's running in production for a year now on mainnet. What we did this year and what we're still working on is, wouldn't it be cool if we use this trusted execution environment to execute transactions, to do the computation off-chain? Since it's running inside a trusted execution enclave, we can still trust it, although it's not running strictly on-chain. The positive points on this are it's local, it's much, much cheaper, because if you consider AI or gaming or whatever, it needs to be fast and cheap. And even the NVIDIA H100s support the trusted enclaves. So you can basically perform computation off-chain and just use the blockchain part for signaling, right? So to manage your off-chain application, to manage the authorization, who can run computation, to bill any users that they want to use your platform for this. So we basically combined both worlds, like the performance from the off-chain world and the trust from the on-chain blockchain. And we call this ROFL. So no pun intended, it's just a runtime off-chain logic, okay? And as I mentioned, this is ideal for the AI if you want to have machine learning, which is confidential, which you can actually prove that your model was trained on a specific set because it was trained inside the TEE, so you can actually trust it. This is cool for gaming because the block waiting time is, as I mentioned, like 3 seconds expected on Oasis. And here you can just open channel in parallel and have an instant response. Anyone familiar with DEXs, the decentralized exchanges, they always need some oracles behind the scenes, to fetch the prices from other chains and synchronize the price quotes. Now you can actually develop an oracle inside ROFL, and you can trust it because it runs inside a trusted enclave. So it won't be any censorship involved because you can actually see the code and verify it that the ROFL is really running what it's claiming to be running. The mandatory sketch looks like this. So each Oasis node can run ROFL app inside the TEE. There's the light client and the attestation because it rests assured that the ROFL really connects to the chain you want it to connect, so you don't connect to any third-party chain that could spoof any of your confidential data. It communicates with Sapphire, so any storage you want to have, for example, storing your private key to access your AI, to decrypt your AI training set, is stored inside some smart contract on Sapphire, for example. But in parallel, you can also open HTTPS connections freely. This is something you cannot do inside a smart contract, right? You cannot just connect to Amazon, whatever, inside Solidity because it's a closed environment. And here you can use ROFL to open HTTPS connections at your own choice, and then do some computation and maybe store it on-chain or just fetch some data from on-chain to process it. Okay, now I made a small example of this. So we are going to build an oracle that will fetch prices from from Binance and store them on-chain, like every block. So this is the Solidity part of the code. Basically, what you do in Solidity is you store this ROFL app ID. This is something similar to what you have in the Chrome Store or Play. So every app has its own ID. Even though it's upgraded to a newer version, the app ID remains the same. So here, we kind of prohibit any other apps accessing this smart contract apart from this app we define in the constructor, I think. Yeah, here it is. So we store the ROFL app ID in the constructor, and then this modifier, only auth app, makes sure that the whichever app is contacting this smart contract, it checks whether it matches the stored ROFL app ID that is allowed to store the price quotes. And the submit observation is the main function which basically just pushes the observation of the price quote. The price quote is here, so it's a value, and it's a block when this price quote was taken. Okay. Now the fun part, this is the Rust code, and this is the code that runs inside ROFL and that does actual fetching of the price quotes. So here it connects to Binance. It checks the rose USDT value. It's a JSON format, so you need to decode it. And then, because, well, Ethereum doesn't know anything about floating point operations, we multiply it by 1,000,000 and have an integer at the end of the day. And then we store this price by calling our smart contract submit observation function and passing this data. And then we set the gas fee, and we sign and submit the transaction using the built-in signer of the ROFL. So this is done all seamlessly, and it connects to the Sapphire, the one who you configured your ROFL to attest with, right? So Sapphire in our case. Right, and then there is some boilerplate. For ROFL, you need to define the trust root. This is the height of the block you trust. It's hash, the runtime ID, so this is the runtime, this is the ID of Sapphire, and the chain context, right? The hash of the Genesis block, basically. The app ID is also stored inside ROFL, and this is basically it. So it runs itself, and then on every incoming block, it runs this run Oracle function, so fetching price quotes from Binance and storing them on-chain. Okay, so for the hackathoners here, I'd like to point out some resources. So Docs Oasis.io is your holy Bible for everything. And then we have the dApps Sapphire subpage, which is all about Sapphire. ROFL subpage for ROFL. If you are building a cross-chain app, then Opal, dApp Opal, is the toolkit you want to use. We have a wonderful playground.oasis.io website, which collects all the previous hackathon projects and any other cool projects, demo projects, educational material running on-chain on Oasis. And finally, I prepared a cheat sheet. You can follow this link or scan the QR code. So it's A4 plain paper, and there are a bunch of links to documentation mentioned here, the wallet, the Explorer, and every other tool you will need to lift off. Okay, so I have a minute, right, yet? So let me just show you quickly that this actually works. So I'm running Sapphire localnet here on my computer currently, and it's running in a simulated mode. That means that you don't need SGX to run it. And here, what I did was, there are a few accounts which are funded, and I also compiled the ROFL I just presented to you, so it's fetching price feeds. And what it does is, so we have, the ROFL is up and running. And if we now check the smart contract part, we should see that the last observed price is 67,000, not dollars, but millions of dollars. So that's like 6.7 cents for a ROSE token, okay? And the block number was 4749. This is running locally, so every second there's a new block mined on my computer. And if I repeat this, the block number increases, and the price, slightly changes every now and then. Okay, so the point being, you can develop ROFL apps now. You can also deploy it on testnet, but you can also deploy it just locally and to test it out, to debug it, and this is already for the hackathoners. All right. Any questions? Yes, go ahead. I would need to check this actually, so I'm not sure. But if you're referring to the messaging, there is no way to directly communicate with ROFL from the chain yet. So you need to rely basically on reading the contract state if something changes, and then reacting on that. So if you want to send a message directly to the ROFL, either you need to open a separate HTTPS connection to some port IP somewhere outside, or you just regularly poll the contract state if there is a message waiting for you. You need to implement this by yourself, like an array of messages, and then get last message and some counter.
There's no limit to how much CPU is actually being used inside the ROFL?
No. No.
So you can keep a connection open, like a WebSocket even?
Yes, so the ROFL, keep in mind that ROFL runs inside the Oasis node. So you must run the Oasis node with Sapphire, and then besides you initialize another ROFL, and then those two communicate with each other. So that's why you can do these polls to the chain very cheaply, because you don't communicate to actually everyone around. You just communicate to your neighbor process on the same physical machine.
Another question, sorry. So once you deploy the ROFL, there's only one instance running, or there's going to be automatically many instances that's actually running. Like how do we decide once we register the ROFL, how many actually run at a time?
So you have the run, first when you register a ROFL app, you define this policy file, this policy YAML file. Inside, you define how many instances there are allowed, and you can also whitelist the nodes. So each node has its unique identity, and you can define the public key, which nodes are allowed to run your ROFL if you want just your limit to a couple of nodes. But at the end of the day, yes, if it's open to everyone, then everyone can load your ROFL and run it. And there's no limit, basically, because the only way they communicate is via blockchain anyway. So there's no reason why not to run. So it's a complete distributed network of ROFLs in that matter, running in parallel with the blockchain. Yeah.
So with pertaining to gas fees, if each of these instances they start submitting.
So each node has its own key pair which it runs ROFL from. So you need to fund each node's instance, yes. And if you're using this built-in mechanism to submit queries, you can always store another key pair inside ROFL if you want, and then use that for signing transactions. But the trusted way of currently how it's done is basically you take the node's key and the node funds your transactions. Yeah. Okay. Yeah.
Let's say we are storing some data in a contract. With help of Oasis, can we make sure that only a couple of wallets can have access to that data, and it will be encrypted for others?
So the Sapphire blockchain is fully encrypted. So whatever you store to the smart contract there will be encrypted. So if you store a wallet key inside the smart contract, that's perfectly fine. And then you need to build your own, smart contract logic in Solidity. Who can access that key? Whose key is that?
We can program that access to this for
Yes, yes. So every smart contract should have some kind of the access control list. Yeah, and it's much more important here because we have a confidential state, and you need to make sure that only specific users can also run queries, because you have this gas cost attack. You can assume what's the internal state of the contract if there are some if statements inside your business logic of the smart contract that depends on the what's the balance of something, then take this path, what's the balance, they take the other path. Then someone could forge the message sender and try to behave like simulate call if I were someone else, and then extract some important data from the smart contracts. So that's why we prohibit doing simulated calls if they are unsigned. If the queries are unsigned, then the message sender will always be 0, regardless of whatever you define it in the call. Otherwise, yeah, if you sign the call, sign a transaction, that means that you are you, and then the message sender is valid, and yeah, you can do the rest of the business logic. Okay. I have one more question, just a quick one, yeah.
So what is the suitable use case for today's that we can clearly see consider of the node fees and other stuff like complementary stuff?
Yes. I mean, you can do ROFL. You can start with the example I showed, maybe, and then do some, fetch price quotes. But yeah, from the 2023 story, like the Sapphire story, you can do the whole myriad, of awesome apps you can do inside the confidential smart contract. Yeah, so gasless transaction is just one thing. You can do cross-chain OPL. You can do login with Siwi. Yeah, so wallet. Your colleague mentioned like on-chain wallet, for example. Yeah. Okay. Thank you.